This video is going to show you how to solve simple stoichiometry problems. You're going to have to write a lot of notes during this video, so you'll probably need to pause and write things down because I'm going to go pretty quickly. The first thing you'll need to write down is you'll need to write exactly what you see here, which is called the mole map. So the mole map basically just tells you how to use moles to convert between mass, moles, and particles. So you can see here, to go from a mole to mass, or mass to a mole, you're going to use the molar mass. If you don't remember how to calculate molar mass, look at the video that's called Molar Mass on the Chemistry channel, and that'll remind you how to get molar mass of a compound. Over here, if you go from mole to number of particles, you're going to use Avogadro's number, which remember is 6.02 times 10 to the 23rd. And it's important to know that those particles can be formula units, molecules, or atoms. So, to learn how to do stoichiometry problems, I'm just going to walk you through a simple stoichiometry problem and show you step by step how to solve it. So with this problem, we're given this equation, and they're telling us that if we're starting with 2 grams of sodium hydrogen carbonate, and they want to know if this reaction happens, how many grams of sodium carbonate are formed. So we can solve this problem using stoichiometry and using those mole maps you just wrote down. So the first thing I know is that I'm started with grams. Grams aren't very good for stoichiometry. We always need to use moles. So we need to get from grams to moles. So if we take out our mole map that you just wrote down, we're down here with grams. We have 2 grams of sodium hydrogen carbonate, and we want to get here to moles. So the way we do that is using the molar mass. Now we ask where we want to go to. Where we want to go to is grams of sodium carbonate. So over here on our mole map, we want to know how many grams of sodium carbonate. So to get from grams to moles, we're going to again use the molar mass over here. So now there's just one more question. How do we get from sodium hydrogen carbonate to sodium carbonate? And the answer to that question is to use what we call the mole ratio. Mole ratio is super easy to figure out because it's the same as the coefficients. Remember, coefficients are these big numbers down in front. So the relationship would be 2-to-1 ratio. The mole ratio would be 2-to-1. So here, 2 moles of sodium hydrogen carbonate to 1 mole of sodium carbonate. So now our whole map is connected. So we can go from grams to moles, then we can go from moles to moles using the mole ratio, and then we can go from moles back to grams, which is where we want to end up. That's our unknown. So now what I'm going to show you is how to set that up using dimensional analysis. So the way you're going to do this, I'm going to show it to you with the dimensional analysis kits, these. And we have these for you to use in class as you're learning how to work these problems. So we always start with our known over 1. So our known in this case is 2 grams of sodium hydrogen carbonate. Then we want to draw the multiply and our next step. So our next step is going to be this one, using the molar mass to go from grams to moles. And when you're trying to figure out what goes on top and what goes on bottom, remember you have to have the same thing on top here as you have on the bottom of the next one so that they'll eventually cancel out. So here we have to have grams of sodium hydrogen carbonate, and we're going to go to moles of sodium hydrogen carbonate. And the number we put here is that molar mass that we've calculated from the periodic table that you have. And that number ends up being 84.006. Okay, so now we're here. We're at moles. So now we want to use our mole ratio to get from moles of sodium hydrogen carbonate to moles of sodium carbonate. So we want moles of sodium hydrocarbonate on the bottom, and moles of sodium carbonate on the top. So we know that for every 2 moles of sodium hydrocarbonate, there's 1 mole of sodium carbonate, because that's our mole ratio that we got from the coefficients. Okay, in our next step, now we're to moles of sodium carbonate, but we need to go all the way to grams. So on the bottom, we're going to put the same thing, moles of sodium carbonate. Then on the top, you're going to want grams of sodium carbonate. So here again, we use the molar mass, and the molar mass of sodium carbonate from the periodic table is 105.988. And if you want to check that at home and look up the molar mass to make sure you're doing it right, I suggest you do that too. Okay, so now we're to grams of sodium carbonate, which is what we wanted for our answer. We need to go ahead and cancel all our units that have 1 on top and 1 on bottom. So we'll cancel grams of sodium hydrocarbonate, moles of sodium hydrocarbonate, and moles of sodium carbonate. And then we're just left with our grams, which is great. That means we set it up right. So now we have to do the math. The math is the easiest part. All you're going to do is multiply all the tops and divide by all the bottoms. So in your calculator, you put 2 times 1 times 1 times 105.988 divided by 1 divided by 84.006 divided by 2 divided by 1. Okay, and then after you put all that in your calculator, the answer you should get is 1.26 grams of sodium carbonate. And that would be your answer to the question. And you just solved it using the mole maps and the mole ratio, and we call these types of problems stoichiometry problems. In your notes, you also need to write down the formula for percent yield. You'll be using this in your lab on Tuesday. So the formula for percent yield is always your actual yield, which is how much you actually produced, divided by your theoretical yield, which is how much you should have produced based on your stoichiometry math. And then you multiply that times 100 to get the percent yield. You also need to make sure that you have the definitions for actual yield and theoretical yield written down in your notes.